We are Sustainable OneWorld Technologies, a social enterprise, and we would like to tell you about our solar cook stove project. In August 2019, we were awarded a grant from the Modern Energy Cooking Services programme at Loughborough University with funding from UK Aid. The programme is looking for new ways to cook food in places like Africa. New ways to cook are urgently needed because wood fuel is no longer sustainable. However, wood has been the cooking fuel in Africa since cooking began, so changing this behaviour is very challenging. We feel that this change will be more likely if, rather than encouraging the purchase of equipment from abroad, the cook stove of the future is made locally and sustainably powered. We seek to maximise positive local impacts. Our proposed locally produced cook stove system will use solar power to create electricity. A controller or power optimization device will manage the electricity from the PV panel. This would direct most of the electricity to the heaters. The heat would then be stored in heat batteries. When needed, the heat batteries would release the heat for cooking. Another function of the power optimization device is to direct some PV electricity to other tasks, such as charging mobile phones. We started with a visit to Malawi, one of the poorest countries in the world, and with the help of our partners, Aquaid Lifeline, we asked the women who do the cooking all about the cooking. They shared key information about what was cooked, when and for how many, but we were also told that they would like to be able to cook 2 dishes at once, and that charging mobile phones would be a big plus. Our technical team then went to work to start developing what was required. First, we built a controller to optimize the output of the solar panels so that we could use all the power that was available. We called this our Power Optimization Device, or POD for short. Secondly, 2 types of heating element were produced, one made from clay and the other from cement and ceramic tiles. Both types of heater worked, were inexpensive, and could be made with materials locally available in Africa. Thirdly, we identified erythritol as our heat store chemical. It is a mass-produced food product and so safe to use and available in bulk. The chemical releases its stored heat at 119 degrees centigrade. We then designed and tested a variety of cooker configurations in the UK. We went back to Malawi, where parts of the cooker had been built. We assembled the cooker there and undertook trials. We also demonstrated to our partners how heat storage batteries worked. Working with our partners and using the sun to boil maize porridge was a moving moment and a milestone for the project. We learnt so much during this work, but we still have so much more to learn. 2 new ideas to share with you: water preheating for porridge and deep fat fryers for micro enterprises. A UK charity provides hot porridge meals to 1/3 of all the primary school children in Malawi. To do this, they heat around 260 tonnes of water a day. Our technology could preheat this water to near boiling temperature, so that the amount of wood needed would be drastically reduced. The other project concerns a micro enterprise. Beata makes and sells mandasi, a form of donut. Mandasi are cooked in a deep fat fryer heated over an open fire. I now know what it feels like to be smoked. We could make a solar powered deep fat fryer, and this would be a great way to show that there are clean and healthier alternatives to wood fuel. We hope that our story has been of interest to you. Please contact us if you would like to explore these ideas further. Thank you for watching.